Okay, that was you driving the car. I would like to just tell you a little bit about the components of the car. Safety is an important issue. How safe is our system? How did we make sure that the car is as safe as possible? And what you see here are a couple of tests which we conducted on the tank. On the top left-hand part of the picture you can see the so-called shaker test. Our tank with the 8 kilograms of hydrogen in the tank was put onto a so-called shaker or shaking bed, and for hundreds of hours we shake the tank in order to see how the system will react, whether it's going to withstand this kind of test. All of these tests have to be carried out for approval so that you are now allowed to drive it. On the right-hand side, we see destructive tests. Tests where, for instance, an iron rod is used, which is dropped onto the tank from relatively high level. We also expose the tank to firearm bullets, and we wanted to see how it behaves under all of these influences, because we wanted to find out when the safety valves will open and how the tank will actually react in such conditions. On the right hand side you can see a crashed car where you can see where the tank was installed, and the most stringent test is 80 kilometers per hour rear end collision, a truck running into the back of the car, simulation of a collision with the truck, and the system then withstood even this test without any damage. So we are proud to say here that this car meets the same safety requirements as our conventional cars. So as a project manager, I can tell you, I can give you these cars and you can drive them like an ordinary car. You don't need an engineer to assist you. Now, what else did we do? Just like with our other cars, we tested it, as I said before, in different continents, on gravel roads, in a very hot environment. We actually went to the Death Valley, we went to Las Vegas, we exposed it to stop-and-go traffic conditions. We went to Norway, Sweden, ice-packed roads. We went to Miramar on the high-speed track, but we also took it to the Nürburgring. And we achieved impressive lap times on the high-speed circuit of the Nürburgring. All of this is possible with the car, which means it's a car which is suitable for everyday motoring. Last week we exceeded the 1 million kilometer mark, i.e. we have already covered 1 million test kilometers, and many thousands of additional test kilometers will be added in the course of time. Now, you drove the car yourselves. There are a couple of limitations. For instance, the luggage compartment, it's relatively small, or the weight of the tank, which in terms of its dynamic, or which does have an influence on the dynamic handling properties. But we are working to provide solutions. The tank will have to be arranged differently in future. We will have to use lightweight materials so that we can eliminate these disadvantages. There's another limitation. There are different provisions for cars of this type. In France, they are not allowed to be driven at all. In Germany, there are a couple of underground car parks where it's not allowed to park any natural gas or gas power cars, no matter whether this is hydrogen gas or any other type of gas. And we don't have any mature codes and standards for storing hydrogen.